Hi guys, welcome to today's lesson. So today we're going to be looking at solving some quadratic equations, right? So this is gonna go from completing the square, factorizing, simultaneous equations, taking out a square root, and all of those other nice, beautiful things that have to do with quadratic equations. But remember, before we get there, we need to look at exactly what is a quadratic equation, because if we do not understand what we're working with, then clearly we'll not be able to then work with what we do not understand. But for now, let's look at our roadmap of what we are actually going to do today. So remember, I just said it's going to be taking out a square root, completing the square, some quadratic formula for questions that you mainly cannot factorize, and then factorizing, and some simultaneous equations. Now, the main thing that you need to think about is what is it that factorization is all about, right? You need to look at what exactly is factorization about. And if something cannot be factorized, what then, right? What then if something cannot be factorized? So that's what you need to just think about, because that's the main thing that we are doing when we talk about quadratic equations. Our keywords will be a quadratic equation and also factorize, because really that's the main question that they normally use under some quadratic equation. So we have what you call the principle of solving. The principle of solving says that if A multiplied by B is equal to 0, then you either have A is equal to 0 or you have B is equal to 0. Why is this the case? It's because if I say 2 multiplied by 3 is equals to 0, it means this will definitely either need to be 0 so that when I multiply with the 3 I get a 0, or the 3 needs to be the 0 so that when I multiply it with the 2 it gives me a 0. Because remember, this equal sign means that you are talking about a relationship between these two sides, that they must exactly be the same, right? They must both amount to 0. Now, a quadratic equation is an equation of the second degree. What do I mean? At least one term needs to be squared, right? And the standard form is normally given by ax squared plus bx plus c. But because we're talking about an equation, we then need to include an equal to 0 there, or an equal to any other number. But the standard formula is normally ax squared plus bx plus c, where the a, the b, and the c are constants. The a and the b, we normally call them coefficients, and then c is the actual constant, like any number for that matter. Even 0 can be the c, but the a and the b are normally called coefficients because they are in front of a variable. Now, to solve a quadratic equation by factorization, one thing that you need to make sure is that the order is correct. So at times I will give it to you, maybe let's say as 3x plus x squared minus 2, right? As soon as you see something like this, you first need to make sure that the x squared is the leading term. When I say leading term, I mean that it must be the very first term that starts, and then the rest of the terms will then continue. So the correct order actually says that the exponents need to be in descending order from the first one up until you get to the last one. So C here, you know it does have an exponent, which is x is equal x to the exponent of 0, which is the same as 1. That's why it's just C. So the exponent of the first term is 2. It goes down, it becomes 1. It goes down, it becomes 0. That's what the descending order is about. Then you need to test for a common factor. Can I take out a common factor from the terms that I have? If yes, do that and then factorize after. But if you cannot take out a common factor, or even after you've taken out the common factor, you then look at the sign of the last term, right? So I said it's ax squared plus bx plus c. So this last term will be the plus there. That will be the sign, right? So if that sign is a positive, Then your brackets will either be a plus and a plus or a minus and a minus. But if this last sign is then a negative, your bracket will then be a plus and a minus or a minus and a plus, depending on which one you put where. But I can advise you to always start with the positive one. It really makes your life easier going forward. Now, let's look at some examples that have to do with this, right? So the first one here, we need to solve for x. The first question has to do with the principle of solving that I was talking about. So let's look at what we need to do. So remember it said, if I have a times b is equal to 0, then my answers will be either a is equal to 0 or b is equals to 0. Now, I always get people asking me, why do we use or? It's because it's either this or that. It cannot be either this and that. That wouldn't really make sense. So it's either you choose this one or you take that one, but both of them do work, especially when it comes to a quadratic equation. But when it's a square root, then there's a different story there that we need to discuss. But we'll talk about that when we get there. For now, let's just solve this one. So my a here will be the x, then my b will be the whole of x plus 3. So it means it will be x is equal to 0 or x plus 3 equal to 0. And then you know to solve for x means that x must be the subject of the formula. It makes it x equal to minus 3. And those will be my two solutions, x equal to 0 or x equal to a negative 3. This one now, you need to use factorization here, right? So to use factorization, you multiply the 2 with the 3, so that will give you a 6, right? And then you write all the factors of 6. It will be 6 and 1, it will be 3 and 2. Now what do I want? I want my middle term to be a negative 1. So it means I definitely need to use the 3 and the 2. So it must be negative 3 and plus 2. So you can simplify this and write it as 2x squared minus 3x plus 2x minus 3, right? And then equal to 0. Then you rearrange this so that you can then factorize it and take out a common fact. So it becomes 2x squared plus 2x minus 3x minus 3 equal to 0. Some people really don't do this. They go straight to opening binomials, which is perfectly fine. But here it's just for people like myself who are still trying to understand this, right? So here my common factor will be 2x into x plus 1. And then my common factor here will be minus 3, which will be into x plus 1 equal to 0. Then already you can see my factors will be 2x minus 3 and x plus 1 equal to 0. Then I have x equal to negative 3 over 2, or positive 3 over 2, sorry, or my x will be equal to minus 1, right? Remember, I'm going to take each bracket, equate it to 0, and then I solve from there. But some people, from the question itself, they go straight to opening the two brackets, and then they then equate each bracket to 0. It's really fine. Remember, it's all about what is it that you understand so that you can get all the marks that you deserve. Now here I have also solved for x. With this one, I will need to square this thing both sides because I'm trying to get rid of the square root there. So this will be squared and the negative 3 will be squared. And on the left-hand side, I will just have x on its own because the squared will cancel with that root, and then it will be equal to, then the negative 3 squared will give me a positive 9 there. And that will be my answer there. So the value of x will just be one value there. Now, this is where the interesting things come in now. Here, what you then need to look at when dealing with these kinds of equations is At the end of you solving the question, you always need to test the two answers that you're going to get, because the likelihood is one of them is not going to work and the other one is going to work, right? Or both of them are going to work. But there's a great chance that one of them will definitely not work. So you need to make sure that you do test them before you can conclude that, no, both of them are answers, right? But let me show you what I mean. So this is going to be, firstly, you make sure that the Z is on its own, equal to x plus 1. And then I square both sides like we did with the previous one. So this becomes x plus 3 equal to, right? I square there, I square here. Remember, this will be a binomial and a binomial, which will be x squared plus 2x plus 1. Then let's simplify this. It becomes 0 equal to x squared. Then the x moving to the other side will be plus x. The 3 moving to the other side will be minus 2. And then I will just write this in standard form for you. So it will be x squared plus x minus 2 equal to 0, because that's really how we are used to it. So at the moment I have x squared plus x minus 2 equal to 0. Let me just verify quickly. Yes. And then to factorize this, it will be x equal to 0. The x and x, the 2 there must be 2 and 1. Because the middle term is a positive, it means my signs must be, the bigger factor must be a plus. Because the last term is a minus, remember I said you need to look at that. The brackets will have different signs. Therefore, x will be equal to minus 2, or x will be equal to positive 1, right? So please remember these two answers, minus 2 and 1. Let's go back to the question. If I substitute minus 2 here, it's going to be square root of minus 2 plus 3 minus 2, right? And this must be equal to 1. If it is not equal to 1, then minus 2 is not one of the answers. So this will be square root of 1 plus 2 equal to 1. So already you can see it's 3, which is definitely not equal to 1. So minus 2, we don't deal with it. Let's look at the other one, which is 1. If I substitute 1 there, it will be square root of 1 plus 3, and then minus 1, and this must be equal to 1. So square root of 1 plus 3 is the same as square root of 4, which is 2 minus 1. It is definitely equal to 1. So 1 will be equal to 1. Then you conclude, therefore, x is equals to 1. Some people even go as far as saying, comma, x is not equals to negative 2. It's really a choice. You can say is that it is just equal to 1 and say it is not equal to negative 2, or you can just leave it as x is equal to 1, or leave it as just x is not equal to negative 2, meaning it is the other one, right? So with this one, guys, what you need to understand with this particular question is, as soon as I give you an equation that has a set, right, a square root, you need to make sure that the square root is on its own on one side, and everything else that is next to it must be then added and subtracted such that it is on the other side. And then only then can you take out a square root on both sides. Why am I saying this? Because let me show you. If I gave you square root of x plus 1 equal to maybe 3, right? And then you choose to just square it from here. If I square here and I square there, automatically you can see that the square root will still be there, because this is going to be x and then plus 2 square root of x plus 1 equal to 9. So the square root is still there. So meaning you still have something that is a bit complex to deal with. So that's why it's just easier for you to always take everything to one side and leave whatever that is inside the square root to be on its own. Guys, I hope that clarifies a few things about factorizing and also about solving for x when you are giving equations that have to do with some square roots and also the principle of solving when you have two brackets that are already factorized for you. Please don't then, the first example, don't multiply out the x inside the bracket. That's just gonna set you back because you're gonna need to go back and then take out a common factor again, which is really a lot of work. So just make sure that you do understand that. For now, I know we've had so much fun so far. I need you to just take a walk a bit and get some water as you are walking so that you can just free your brain, because I know algebra can be a bit daunting for you, but I'll be back with some more just after the quick ad break.